Welcome to aminacademy.com. In NIOS 10th Standard Mathematics, let us discuss about source. Numbers that are irrational and cannot be represented in the form of fraction or as recurring decimal numbers are known as surds. These numbers cannot be represented as recurring decimal or as fractions. They can be only represented as square roots. In other words, surds are nothing but square root representation of irrational numbers that cannot be expressed in fractional or recurring decimals. In order to make precise calculations, surds are very useful. Look at this here. Root 3 is surds, which is a square root representation. Root 3 and root 5 cubic root of root 9, like these are surds. Next we will discuss about simple surd. When there is only a number representing the root symbol, then it is called as a simple set. For example, 2 minus root 2. Here in your root 2 symbol 2 is there, and 5 minus root 5. Here root symbol it is 5. Pure surd. Surds that are irrational are called pure surds. For example, 3 minus root 3. Similar surds. When surds have the same common factors, they are known as similar surds. For example, here root 5 and root 3 are similar surds because both are in square roots. Mixed surds. When numbers can be expressed as a product of rational and irrational numbers, it is known as mixed surds. For example, 5 root 2 is a mixed surd because here 5 normal number is multiplied with the square root 2 is a mixed surd. Compound surds. The addition or subtraction of 2 or more surds is known as compound surds. For example, root 5 plus root 3 is a compound surd because addition or subtraction of 2 surds. Here we will discuss about law of surds. Here nth root of a power n is a. That is, here nth root of a can be written as a power 1 over n into n is n cut, it will come a. Like nth root of ab is nth root of a into nth root of b. That means it is the product inside the square root is separated as a square roots. Then nth root of a over b, that's a quotient, is equal nth root of a over nth root of b. Here next, nth root of a power m is nth root of a power m. Nth root of a is mnth root of a. Now rules of surds. Square root of ab is square root of a into square root of b. Normally you can use square root of 2 into square root of 2 into 3 is equal to square root of 2 into square root of 3. Like division, square root of a over b equal to square root of a over square root of b. Next, third rule, b over square root of a is equal b over square root of a. Here rationalizing, that means in denominator square root of a is there. That same number you have to multiply up and down. It becomes b square root of a over square root of a into square root of a is a. That is, here in denominator there is no surd. It's a pure rational. That is normal number here. Then square root of a into square root of c plus or minus b into square root of c is equal to, then we can take out, because square root of c is a common factor, take out, then a plus or minus b. Then c over a plus b square root of n. Here multiply top and bottom by that rational. Yeah, that means a minus b into square root of n. It becomes a minus square root of b into square root of n. Here same square root of c over a minus b into square root of n. Multiply top and bottom by a opposite of sign is here minus here plus a plus b square root of n. This is called a rationalizing the denominator. We'll discuss this in example in future videos also. Here, similar and dissimilar surds. We will discuss about similar and dissimilar surds and their definitions. First, definition of similar surds. Two or more surds are said to be similar or like surds if they have the same surd factor. Or two or more surds are said to be similar or like surds if they can be so reduced as to have the same surd factor. For example, look at here, square root of 18 and square root of 27 can be said to be similar surds because square root of 18 can be written as 2 into 9 and square root of 27 is 3 into 9. Here square root of 9 can be taken as 3, then you know 27 will get it. Suppose okay, I can do this one. Here square root of 18, 2 into 9 and 2 into 9 and suppose 45. We'll give some other example. Look here, look, suppose 49 square root of 8 and square root of 50. Here square root of 8 can be written as 2 into 4 and square root of 50 is 2 into 25. Here 4 square root is 2, take out, that is 2 root 2 and 5 root 2 because square root of 25 is 5. So it's taken as 5 and root 2. Here these are called, that is square root of 8 and square root of 50 is called similar surds. Then we can say square root of 8 is 2 root 2, square root of 50 is 5 root 2. So inside the square root sign both numbers are same, so it's called a similar surds. If inside the square root number is different, we can say it's a dissimilar surds. Now simplest form of surd. A surd is said to be its simplest form when the number under the root sign has no square factor. For example, square root of 72. Square root of 72 is written as square root of 2 into 36. Square root of 36 is 6 and root 2. Then, so we can write as square root of 72 is 6 root 2. Then the surd is said to be the simplest form when the number under the square root sign has no square root factor. For example, square root of 72 can be reduced as like, then 2 into root of 18 is 2 root of 9 into 2, then square root of 9 is 3, 3 into 2 is 6, so 6 root 2. Now we can say, for example, check whether square root of 96 is surd or not. Look at here, square root of that is 96. 2 is 4, 48, 2 is 24, 2 is 12, 2 is 6, 2 is 3, 3 is 1. So here inside the square set of 2 we have to take 2 and 2, and here this can be written as 2 square and another 2 square, another 2 into 3, which can be taken out. 2 is taken out because square root of 2 square, and another 2 is taken out, and square root of 6. Here 4 root of 6. Here then we can say the square root of 96 is a surd. Now suppose cubic root of 81, whether it's check surds or not. Here 81 can be written as 3 into 3 into 3, cubic root of 3, then cubic root of 3 cube, which is equal 3 cube power 1 by 3, then both factorial 3. So it's not a surd, not surd, which means cubic root of 81 is not a surd, but square root of 96 is a surd. Now then other example we can do, find index and radicand, of suppose 162. Here square root of 162, in this simply you can say index is 2. Index is 2. Since here square root means here 2 is there here. Index and radicand is 162. Like that. Cubic root of 30, here index is 2 because square root, and radicand is 3. It's a cubic root. Index is 3 and radicand is 30. Here because it's a cubic root, so index is 3 and radicand is 30. Here next here discuss this one is root or not. Root 5 into root 80 is surd or not, is surd or not. How to say it is a surd or not? Here first inside 5 into 80 can write, because square root of 5 into square root of 80 is like that. Here then 5 into 80 can be split as 2 is 40, 2 is 20, 2 is 10, 2 is 5, 5 is 1. So here we can write as 2 square into 2 square into 5. Here 5 further we can write this 5 square, 2 square, 2 square, because 5 is double time. So take out 5, 2 into 2 is 20. Here therefore root 5 into root 80 is not a surd because 20 is not a surd. Therefore, it is not a surd. That means square root of 5 into square root of 80 is not a surd because there is no radicals. Now, further discussion will continue in next videos. If you have done, please subscribe our YouTube channel.